Hello, hello students. I am Sanjay Singh, Assistant Professor, Government Engineering College. Today we will learn the 8085 microprocessor architecture, its functional block diagram, its buses, its registers, etc. As we know, 8085 microprocessor is a 8-bit processor. It is also pronounced as 8085 microprocessor. It's a 8-bit technology microprocessor designed by Intel in 1977. It has 8-bit data bus. First of all, we have to learn that what are the buses. Buses are what? Buses are the group of wires and each wire can capable to carry 1 bit of information. If a bus is of 8 bit, it means that there is 8 wires are there and each wire is capable to carry 1 bit of information. It means if there is 8-bit bus, then there is a group of 8 wires are there. In 8085 microprocessor, three types of buses. One is called data bus. Data bus is of 8-bit length. This bus is bidirectional. Bidirectional means this bus carry the information and data from microprocessor to device memory and vice versa. Uh, Out of this data bus, there is 16-bit address bus which can be addressed to 64 KB of memory. 64 KB of memory. Why it is 64 capable to address 64 KB of memory? Because 2 to power 16 equals to 64 KB. 8085 microprocessor have 16-bit address bus. This bus is unidirectional. It means this bus can carry the address from microprocessor to memory or input output devices. It have 16-bit program counter. This is a register that carries the address of next instruction to be executed. 16-bit stack pointer is another register that is used to store the address of the temporary memory that is used during program execution. It have six, 8-bit registers arranged in BCDEHL. Means there is 6 general purpose registers, that is B, C, D, E and H and L. One special register that is called accumulator. This is also 8-bit register and this is the part of ALU. 8085 microprocessor requires 6 plus 5-volt DC power supply to operate and 3.2 megahertz single phase clock to work. It is used in many applications like washing machine, microwave, oven, mobile phone, etc. So let us discuss about the architecture of 8085 microprocessor. Here is the architecture block diagram of 8085 microprocessor. You can say in large form like this. Uh, uh, we have to start from here. Here is the that address bus, that is AD0 to AD7. This is multiplexed address data bus that is used to carry the data from to and from microprocessor and peripheral devices as well as memory. Here is the address bus. As we have already discussed that data bus is bidirectional bus, address bus is unidirectional bus. Address bus is from A0 to A15. This is the higher order address bus and this is multiplexed address data bus, means this bus is used to carry both the data and address as well. In a separate video, we will discuss that how to demultiplex these address and data from same bus, as we have already studied in pin diagram that ALE signal is used to demultiplex this. Here is the set of registers. This is the set of registers that is used in microprocessor. Every microprocessor, every processor have some set of registers. These registers are used to store the data that is accessible fastest. B, C, D, E, H, and L arranged in this form. W and Z, these two registers are the temporary registers, and these registers are not accessible to the user. These registers are used by microprocessor itself to process the data. B means base register, C means counter register, D means data register, E means extra register, H higher, L or lower. These are every register of 8-bit length, and if we want to store data more than 8-bit, then we have to pair them. Pair will be always in form of B, C, D, E, and H, L. These two registers, one is called stack pointer, one is called program counter. These are 16-bit register that is used to store the address of the program. Program counter is a 16-bit register that is used to store the address of next instruction to be executed in the program. So we have to cover the address bus, data bus, and registers. Now, as we have discussed in pin diagram, there are various signals to and from the microprocessor will be to manage the external devices. This is this portion is used for serial input output control. Serial input data that is come from the serial input devices, and serial output data that is generated by processor or the serial uh, devices that is attached with the microprocessor. This section is used to handle the interrupts. Highest priority interrupt trap, that is non-maskable interrupt, RST 7.5, 6.5, 5.5, and INTR. This is the level of priority higher to lower. One signal that is active low signal INTA. INTA means interrupt acknowledgement. This signal is used by the microprocessor and to the peripheral devices that generated the interrupt signal. One more register that is called accumulator. This is also 8-bit register, and this is the part of ALU. ALU means arithmetic logical unit, and every arithmetic and logical operations, one of the data should be always stored in accumulator, and the result of that operation will be also stored in the accumulator. Temporary register is used by the ALU to generate the temporary results. One more register that is also 8-bit register, but uh, it is used only 5 bits, that is called flag register, that we will discuss later. Here the instruction register that is also 8-bit register, and this register is used to store the opcode that is carried from that is read from memory. Opcode means operation code, that what operation is to be performed, and when every instruction is executed, first of all the opcode of that instruction is fetched, and that opcode is stored in instruction register. From instruction register, opcode will be given to the instruction decoder, and instruction decoder will decode that opcode and find out the size of instruction, the work of that instruction, that what operation will be performed by that instruction. This is the brain of the we can say this is the brain of microprocessor, that is timing and control, that controls the all the functionalities and control and timing signals generated by the microprocessor. These are the power supply signals. These are the frequency signals x1 x2 that carried from oscillator. Clock out signal, ready signal. Ready signal is generated by peripheral devices, that the device is ready to work with processor. Read signal generated by microprocessor for read operation. Write signal generated by processor to signify the write operation. ALE are address latch enable. This is used for demultiplexing of the address database. These are the status signals and input output with memory. These signals we have already discussed. These signals in combination generates 8 operations that we have already discussed in pin diagram of 8085 microprocessor. HOLD and HLDA. These are the hold and hold acknowledgement signals for DMA request. It means direct memory access. Reset in and reset out. These signals are used to reset the microprocessor and reset the input output devices. Uh, so, in view of if we discuss the buses are of three types: address bus, data bus, and control bus. So, as we have already discussed, address bus is of 16-bit, data bus is of 8-bit, and control bus is of single bit that carries the control information like read signal, write signal, ALE signal, etc. So these are the basic things behind the architecture of 8085 microprocessor. Hope you have understand the architecture block diagram of 8085 microprocessor, the register organization of 8085 microprocessor, and the buses of 8085 microprocessor. Thank you so much.